What's good? This is Mr. Ngobeni from STS. We are doing trigonometry today, and yeah, you're welcome. Hello, and welcome to today's episode of our metric revision. We will go through past papers. Today, we are focusing on trigonometry. Okay, without any waste of time, let's get straight to the question. So it reads as follows. Given that sine of alpha is equals to negative 4 over 5, and alpha is between 90 and 270, without the use of a calculator, determine the value of each of the following in its simplest form. So here they say without the use of a calculator, without using a calculator. This is key. This is key, right? And this suggests something. It already tells you that you must use a sketch. So sometimes they will say without the use of a calculator and with an aid of a sketch, right? So in this case, they didn't say with the aid of a sketch, but we need to know that in questions like this, you must draw a sketch, you must draw a what? A Cartesian plane and then put your right angle triangle. And that's what we're gonna do. So what we then have is our Cartesian plane, and this is 0, this is 90, this is 180, this is 270, this is 360. In the first quadrant, what we know that all of them are positive. Second quadrant, so here all of them are positive, only sine, only tan, only tan here, and then only cos there, right? Okay. Hello and welcome to today's hello and welcome to today's episode. Hello and welcome to today's episode of our revision lessons where we go through past papers for matrix. Today we are focusing again on trigonometry, right? So without any waste of time, let's read the statement from the question. 3.1. Given that sine alpha is equal to negative 4 over 5 and alpha is between 90 and 270, not included, without using a calculator, determine the value of each of the following in its simplest form. So we supposed to do this without using a calculator. What that tells us is that we actually need to use a sketch. So sometimes they'll say without the use of a calculator and with an aid of a sketch. But in this case, they didn't say with the aid of a sketch, but you need to know that it means the same thing. So what we do is we draw our sketch, and our sketch is a Cartesian plane, and this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So you've got 4 quadrants there. This is 360 degrees. You need to remember all of them are positive here. Only sine is positive there. Only tan is positive there. Only cos is positive there. All students take coffee. Okay? Now, this is how we do this question. Firstly, you're going to use the restriction. The restriction says draw your right angle triangle in which quadrant? You must draw it either in quadrant 2 or 3. Based on what? Based on the restriction. Because the restriction says from 90 to 270. That's where alpha is. So it can either be in 2 and 3, or 2 or 3. However, we must use the sign of our trig ratio. The sign of our trig ratio. In this case, the sign of our trig ratio is negative. So our trig ratio is negative. So because our trig ratio is negative, that means you must do what? You must draw it where sine is negative because our trig ratio is negative. So we need to put a tick where sine is negative. So sine is negative in the fourth. So sine is negative in the fourth and the third quadrant. So we put ticks there. And the quadrant with the most ticks is where you draw your what? Is where you draw your right angle triangle. So we're going to draw a right angle triangle in quadrant 3. So here's a right angle triangle. Now, your alpha is always from the positive x-axis to the terminal. So your angle is always from the positive x-axis to the terminal. So that whole angle is alpha there, right? Now, sine of alpha is -4/5. So sine of alpha is equal to -4/5, right? Now, that means 4 is the opposite, and the hypotenuse is 5, because hypotenuse is always positive, right? So this will definitely be -4, and this will be 5, right? Now, what you need to do is you need to use Pythag to find what? To find the third side. So what we have here is r squared is equals to x squared plus y squared, and this is Pythag. Now, what we then need to do is to say we have 5 squared, which will be x squared plus -4 squared. So this is 25 minus 16 is equals to x squared. So 9 is equals to x squared. Square root. X can either be negative or positive, but because this is in the third quadrant and x is negative there, you're going to say it's -3, right? So now let's go and answer our questions. We've got sine of negative alpha. There is a negative angle. You're going to add 360. So it's going to be 360 minus alpha, which is in the fourth quadrant. And in the fourth quadrant, sine is negative. So this is going to be negative sine alpha. So negative sine alpha will be 4/5. Now cos of alpha, we already have our adjacent, which is -3, and our hypotenuse, which is 5. Sine of alpha minus 45. So you see here, for example, this angle will be 90 minus alpha. So you don't have 45, uh, alpha minus 45. However, what you can do is expand this using what? Using the compound formula for sine. So this will be sine alpha times cos 45. And remember, when it's a cos compound formula, the sign remains the way it is. So it's still going to remain as minus, right? But now you're going to start with cos of alpha times sine of 45. Now, what we then have here is special angles. And this is what I use for special angles. I use 2 right angle triangles. So I use the 45 one. And this is an isosceles triangle. This will be 1, this will be 1. That will be square root of 2, right? Using Pythag. I also use this one for 30 and 60, right? And I cheat for this one. I say, what is the square root? What is sine 30 in my calculator? It gives me 1/2. And then cos 30 will be square root 3/2. So these is the 2 right angle triangles that we use for special angles. So we're going to have sine alpha times 1/square root 2, right? Minus cos of alpha times 1/square root of 2. But someone would say, but you already have sine of alpha. So what was sine of alpha? It was given to us as -4/5. So it's -4/5 times 1 over square root 2 minus negative 3 over 5 times 1 over square root 2. Now this gives you negative 4 over 5 square root 2 plus 3 over 5 square root 2. Now you see the denominator is the same. You can add the numerator. So you've got negative 1 over 5 square root 2. That is your final answer. Now, the next question is saying, consider the given identity. And from the given identity, you need to go and prove that identity. So what we do is we take the most complex side, so which is the left-hand side in this case. So the left-hand side, we're going to simplify it. Sine is positive in the second quadrant, so this will be sine x. Now, usually what you have is you've got 360 minus x, but then you've got x minus 360. So you need to understand that that is a negative angle. So what you need to do is to add the 360. So when you add 360, what you usually actually get is cos of x. So you get cos of x there because you're going to add 360. So you add 360 here because it's a negative angle. And then you've got sine squared x. Now, because there is 90 plus x, right? And it's 90, then in sine changes to cos is a cofunction. So that will be, because sine is positive in the second quadrant, right? It's going to be what? It's going to be positive cos squared x, right? So this, and again, because it's positive and it's squared, it will definitely be a positive, right? So it's going to be positive cos squared x, right? That's what we're focusing on. So we've got 8 sine x times cos x over sine squared x. This is going to be minus cos squared x, right? So what are we then going to do with that? How can we play around that? What if, so sine squared x minus cos squared x, what is that? We know that we can take out a negative here actually, and then write this as cos squared x minus sine squared x, right? Which is the double angle for cos. So this will actually be 4 times 2 sine x times cos x. I'm creating the double angle for sine at the top and then the double angle for cos underneath, minus cos 2x. Now, what you then realize is you're going to have 4 times 2 sine x times cos x is actually sine 2x over cos 2x, but negative. So this is actually negative 4 tan 2x, which is the same as the right-hand side. So you've proven that the two sides are equal. So you've proven that identity. Okay, next question. For which values of x in the interval 0 to 180 will the identity be undefined? So the identity will be undefined when the denominator is equals to 0. So this builds from our understanding of fractions. Say if you have got a fraction a over b, this will be undefined when b is equals to 0, right? When the denominator is equals to 0. So For our identity to be undefined, that means the simplified form of our denominator, which in this case we simplified it to negative cos 2x. So this should be equals to 0, or cos 2x should be equals to 0, whatever you prefer. So what we are saying is that cos 2x should be equals to 0, for our identity to be undefined. And then what do we need to do? We need to do the general solution for this. But firstly, we find our reference angle. Find our reference angle, right? And your reference angle will be 90 degrees. That is your reference angle. So you have your reference angle now, which is what? Which is 90 degrees. Now from there, you have your reference angle. What do you then do? Okay, use the formula for cos. The formula for cos when it comes to general solutions is your angle is plus or minus the angle that you found, your reference angle, plus 360. K is element of integers. Now you're going to divide by 2 to find your simplified general solution. Plus or minus 45 plus 180 K. However, in this case, they gave you a restriction, which means you are looking for specific solutions. So you're going to substitute different values of K to find answers in between the interval of 0 and 180. So if we substitute K with 0, what we get is 45. If you substitute K with 1, you can also get 135, because 180 minus 45 would be 135. And those are the two solutions that you have. So that is your answer for this question: 45 degrees and 135 degrees. The next question reads as follows. Determine the general solution of cos 2 theta plus 4 sine squared theta minus 5 sine theta minus 4 is equals to 0. Now, the challenge that we have here is we have sine and we also have cos. However, our sine is in the simplified form. For example, sine theta, the negative 5 sine theta. So which means we need to change the cos 2 theta to one of the compound angle formula, or rather double angle formula. So we must choose the one that changes to sine. When I say this is 1 minus 2 sine squared theta plus 4 sine squared theta minus 5 sine theta minus 4 is equals to 0. Now what we have is we have like terms. You see, you've got these like terms. So you must simplify this by looking at like terms. Those are like terms. And these will be like terms. So what do we get? We get 2 sine squared theta, right? 2 sine squared theta. And then we also get minus 5 sine theta. 1 minus 4 is negative 3. This will be equals to 0. Now you need to recognize that this is a what? This is a trinomial. It's a quadratic equation. So what you then have is you're definitely going to have a 2 sine theta and then we're going to have a sine theta. We are factorizing that. And then what are we going to do? Now we're going to find factors of 3 or -3, right? But we want to get our -5. So what I'm going to do is I'm going to put -3 here because that will give me -6. And then this, I'm going to put this as +1 because that will give me +1. So -6 plus 1 gives me what? It gives me the answer of -5. So that is actually factorized properly. Want to make sure that you get your middle term. So we have factorized our quadratic equation. So now what we then have, it's actually sine theta will be -1/2, or sine theta is equals to 3. However, sine theta will never be equals to 3 because the graph of sine theta has the range of -1 to 1. So this will never be, right? So that means we need to find the general solution of sine theta is equals to -1/2. So you find the reference angle. You find your reference angle. And the reference angle is -30. And then from there, you use the formula for sine, right? The formula for sine says your angle be equals to the reference angle plus 360 k. K is element of integers. But that is not the only one you have. Also have the second one which says, or take 180 and minus with your reference angle plus 360 k. Its element of integers. So our second general solution will be 210 plus 360k. Now that is our solution. Thank you very, very much for watching this episode of our trick revision. We are focusing on trigonometry. So we got you, and I want to say to you, all the challenges that you have in mathematics will be fine with STS. We are here to help you best way that we can. We'll be loading more content in different topics. The first topic that we are dealing with is trigonometry, and then we're gonna go on into Euclidean geometry thereafter. But thank you for watching today's episode. We'll see you in the next one. Bye.